Alright, hello guys, welcome to my channel, and if you're yet to subscribe, please click on the subscribe button, and also click on the notification button so that you can get notified whenever I post content like this and more. So today we are going to look at simple linear regression in Excel. And what is simple linear regression, you might ask? So this is just like it's a statistical model that we can use to model the relationship between two continuous variables. In simple terms, you just want to see how two variables are related to each other, and then probably use it to make predictions about what will happen in the future if you maybe change one of the variables. So before we start to do a practical case, it's also important that you understand some basic concepts. So I always start by explaining some concepts that you need to understand before you can really grasp what is going on, in the Excel sheet. So let's dive into Excel and see some of the concepts that we need to understand before we proceed. Yes. So let's start with the concept of a straight line graph. So whenever two things are related, two things are related, we can represent the relationship in a straight line graph. Here's what I mean. Assuming you have maybe you're doing a business and then your price or your profits is dependent on your price. Whenever you have a data like this, you have, if your price is 5, this is going to be your profit. If it's 10, it's going to be 10. If it's 15, it's going to be 15. Then you can represent this relationship in a graph. And so we have something like this, where we can put, usually what happens is that we put the variables that are independent on the x-axis. What I mean by independent is that does not depend on, based on the values we have, it does not depend on any other variable. It is discrete and distinct by itself. So in this case, it is going to be the price, because the profit will now depend on the price. So the price is independent variable, and we put it on the x-axis, and the profit is the dependent variable, so it is depending on the price, and we put it on the y-axis, right? So all we have to do to get a graph is just, whenever we come to the x-axis, which is the independent variable, and we check what is the value in the y-axis, and then usually this is a graph sheet and usually have this line, so you just come to where the two lines meet, and then you put a dot, right? And then you go to the next one. When it's 10, it is 10. You come to 10, and then draw the line, and then where it meets the y-axis, yeah, put a dot here. You do the same thing for all these other variables, and then you connect the dots, right? And then you've gotten a straight line graph that demonstrates the relationship between the price and the profit of a business. So now it's not going to it's really not this case where you have that whatever the price is going to be the same thing as the profit. So this is just like the most simplistic case of a straight line graph, where the independent variable will always be equal to the dependent variable. So we have that the profit is equal to the sales, right? So like I said, this is the most simplistic form, right? So we can use variables to represent this. You can say that the profit is y, and the sales, let's say profit and price, sorry, not sales, profit and price. Oh god, what am I doing? The profit is equal to the price, right? So we can use variables to represent this. So our profit that we put in the y-axis, we can use y to represent it, and then our price that we put in the x-axis, we can use the x to represent it. So this means that if you want to plot a graph of y is equal to x, it's going to be a straight line graph that passes through the origin. The origin means the 0 point where y and x are 0. That is this point. So that is the graph of y is equal to x. Now this is the most simplistic case, like I've said before, and it is not usually like this. So it is usually like this, where you have that y will not always be equal to x, but there will be a relationship. It's going to be still a straight line graph, but then there will be a relationship between the two variables. So how do you determine the relationship? So it means that y is equal to a factor. So y is dependent on x, but then it is dependent on x by a factor. So we call that factor the gradient or the slope of the graph. So for instance, if you come here, you see that when the x is 0, when the independent variable is 0, let's say this is the price now. So price is 0 here. Then y is even negative. The profit is negative at 0. When the price is 1, the profit is, let's say, 0.5 minus 0%, negative 0.5. So the business is probably making a loss. Then we only begin to make a profit when x is beyond 2. So at this point we begin to make a profit. So it means that the profit is dependent on x, but by a factor of a number that we don't know. So how do we get this factor? So the way we get the factor is if you have drawn a graph showing the relationship, and then you do a slope, which is the change in y divided by the change in x. So in this case, you say, what is the value here? This is 3 minus 0, right? 3 minus 0. Let me put it down. 3 minus 0 is 0. It's 3, sorry. Divided by change in x. Change in x here is 8 minus 2. So we have 8 minus 2, which is 6. So yeah. So we have, this should give us 0.5. So our x, our gradient, our slope is 0.5, right? 3 over 6, 0.5. Then, so what it means is that ideally, once we know the price and we multiply it by 0.5, we should get what the price is, right? But then let's try. Let's say that the slope is 0.5 times 0.5 times what? Times the x. Let's try a case where it is 2. We already know that it's supposed to be 0. Then let's put 2 here. 0.5 times 2. Now 0.5 times 2 is going to be equal to 1. So when x is 2, y is not equal to 1. It is not equal to 1. Y is equal to 0. Why is that? Now let's try another case. Maybe this one is trying to misbehave. Let's try and see when y is when x is maybe x is 5. Or let's use this one that we have a point. When x is 8, so 0.5. So the slope is 0.5 times 8. 0.5 times 8 is supposed to give us 4, right? But then we have that when x is 8, y is 3. So it means that there's something we are not accounting for, and that's what we call the intercept. So the intercept is what the value of y is supposed to be at the base level when the independent variable is 0. So when x is 0, what is it for y going to be? And then after that value, then y begins to increment by a factor of the slope. When we increment x, the y will now increase by a factor of that slope, depending on the value of the x. So in this case, what is the value of y when x is 0? That is at this point. X is 0 here, so the value of y is minus 1. So it means that minus 1. So this is our base level. So it means that this is the minimum value of y that y will attain. So whenever we use our slope to get the value of y, we add this value. So for instance, in this case where we have gotten that when y is 2, we just add plus minus 1 or minus 1, as the case may be, minus 1. So 1 minus 1 is supposed to be 0. 1 minus 1 is 0, so we are going to get 0. So that will be right, because when x is 2, y is 0. So that is right. So I'm gotten it now. So if you also add the minus 1 here, so 4 minus 1 is going to be 3. So when x is 8, y is 3. So you've gotten it. So you can see that the concept you need to understand here are the slope and why you are getting the slope, and the intercept and why you need the intercept. So if you understand these two concepts, then you've understood simple linear regression, right? So slope is the factor by which the dependent variable, in this case the profit, is going to be increasing by unit increase in the independent variable, in this case the price, or the x-axis value. So y will increase by a factor of the slope when you increment x, and then the intercept that you need to add at the end is the minimum value of the y when x is 0. So whatever you get when you multiply the slope by the x value, you add the intercept to it, and you get your value of your y. So okay, so now we understand what is slope and what is intercept, and why we can have a formula like this where you say y is equal to slope times x plus intercept. So at any point along this line, assuming we want to extend this line to infinity, we can always know what the value of y is based on what the x is. We can predict what the profit is going to be, at infinity price, whatever price we want to fix. So just come here, plot it in. We already know our slope. We know that our intercept is minus y, and that our slope is 0.5. Our intercept is minus 1 and our slope is 0.5. Then you just come here and you put it in, and you get what the profit is going to be. So this is what we call the equation of a straight line graph, which says that y is equal to the slope times the x plus the intercept. So you just come to a typical case of a simple linear regression where we have that we have a data like this, where the production, maybe this is a meat production company, and the daily production is dependent on the temperature deviation, or the temperature. Let me just use temperature, right? So we want to predict what is going to be the meat production when the temperature deviation is 26. So how can we do that? So first of all, we need to know whether this thing is even a linear relationship to start with before we use simple linear regression, because there are different kinds of relationships. There are relationships that does not fit into that straight line graph equation that we had earlier on. There are relationships that are cubic, they are quadratic relationships, so those ones you cannot use simple linear regression to predict or to make predictions. So let's use a graph to see how to see whether it is a linear relationship. So we just click on any point in the table you want to plot a graph, and then press Ctrl A to highlight the table. Then you go to recommended charts, or you can select the chart by yourself, and I think a scatter plot will give us the best idea of how these things are relating. Then you might add a trend line to see. So you can see that you have it's a direct relationship, but in this case it is inverse. So it means that as the temperature is increasing, then the production is reducing. So but it is still a straight line relationship, right? So what do we do? The first thing we need to do is to get our slope, because we know that we can relate this in a straight line, although this is not really a perfect straight line, because ideally all these lines should be on this line, all these dots should be on this line. So this is not really a perfect model. We can't really depend on this as our production. You can see that the margin of error is going to be high. You can see how high this is falling off from the line, but we can still use this to just illustrate. That is why simple linear regression is not really the best model to use to make your prediction about your, you know, maybe do a forecast. It's just a way to explain some concept. When you understand this, then you can actually go further into maybe multiple linear regression and maybe some more complex prediction models, right? So we get our slope, and I believe that by now you understand why we need to get our slope. So we have we don't need to stress ourselves. Excel has the formulas for us, so we just type this and then tab button to complete. Then it tells us what is our known y's. Known y's are the ones that we know already that are depending on another variable. So in this case it's production, so we just select all the production, right? Then the comma, you see x, non-x's. So non-x's are these ones, right? Then close the bracket, and then we have gotten our slope. So this is going to be our slope, so we'll label it our slope. So what else? We need to get our intercept, so we can have a form, so we can have, you need to get this and this, right? So we can put it into an equation like this and then predict what the production will be at that 26 degrees. So yeah, so we get our intercepts, which is equal to, again, Excel has the formula for us. The intercept, the known y's, our daily production, and then our known x is our temperature deviation, right? So this is our intercept, right? I mean, the decimal numbers are looking quite weird, so let's reduce it to look nice. So the next now is for us to put it into this equation of a straight line, that y is equal to slope multiplied by the x plus the intercept. We can call the intercept c, or we can type it in full. So in this case, our y is our daily production, so and our slope is this. So we can say that to predict what the value is going to be here, we say that it is equal to the slope, right, multiplied by x. The x is going to be this that has been given to us, right? Then you say plus the intercept. The intercept is this value, and you click on enter. So it has predicted that at 26 degrees temperature deviation, we are supposed to have 120 packs of our products. This is going to be our daily production. So you can see that it is maybe, yeah, probably around here. You can see why this is not a good model, because it is not really, you can see that even at 27 we're having 316. So it's not really so you can't really trust this model to make a prediction. That is just the point I'm trying to make. But this is essentially how you do a simple linear regression, where you have that one value is depending on another single value. Now you can have a case where you have multiple parameters affecting the daily production. Maybe aside the temperature, maybe the humidity can also be affecting the temperature. You may have another column here showing the daily humidity. You may have another column showing maybe the I don't know, maybe the sunshine level, or maybe just any other value parameter that can affect daily production. So in the same vein, so maybe we're not going to have x1, x2, so all of them are going to have their own slope. So this is what I mean. It means that you're going to have multiple x's. Slope 2 times x2 plus slope 3 times x3. Just like that. So when you have multiple factors affecting it. And that is where multiple linear regression comes in. So in the next video, I'm going to make a video on how to do multiple linear regression. It's not as straightforward as this. You're not going to do it as straightforward as this, because you need to put some of that into consideration. And there is Excel has a tool to help you do that kind of regression. So I will do it in the next video, and click on the subscribe button if you have not subscribed, and then click on the notification bar so that you know when I post the video. Alright, so thank you for watching. If you have any questions, put it down in the comment section and I'll do well to attend to them. Thank you.